Here's a second example of converting from the world of XYZ, called rectangular coordinates, into the worlds of cylindrical and spherical coordinates. Again, this is not intended to be first-timers. This is somebody who just wants to hear it walk through that's already had a little bit of introduction. So for this example, we're going to let our rectangular coordinates be 0 to -2. And so if this were the x-axis and this were the y-axis, this would be our top view. So z is not there, as we're very accustomed to in 2 dimensions. The point 0, 2 is 2 units up on the y-axis. And that would give us our radius of 2. And it would also tell us that theta is pi over 2. And of course, z is given to be -2. So when we write our cylindrical coordinates, which are the polar coordinates plus z, I often nickname, the radius is 2, theta is pi over 2, and z does not change, is -2. Quick and easy conversion, but we need the theta and maybe even need the r moving forward to finish the conversion to spherical coordinates. Let me just slide this up here so we can do that. So then I've always request my students to then consider some form of a side view. This is usually to help visualize what the angle phi is, but let's just remind ourselves is that we have, theta is pi over 2, calculated from above. And if we want to find out what the radius rho is, there's several formulas, but you could use a short one that fits here, r squared plus z squared equals rho squared. Or you can do x squared plus y squared plus z squared equals rho squared. They are the same. We have the radius, r, which was 2, and z, which is -2. Give us what rho squared is. And rho ends up being the square root of 8, or 2 root 2 if you feel like your algebra teacher would be frustrated if you wrote it this way. Now then, question is, what might our angle phi equal? Well, you might be able to do it without a calculator sometimes. And so for our diagram here, if this is the y-axis and that point is 2 units along the y-axis, and well, that's no good. I'm going to draw my axis there again. Like I said, real world, none of this fake video editing stuff where it looks like it's perfect every time. So if we go 2 units in the y direction and down 2 units in the z direction, side view would show us a point right there. Let's change it to this color. There we go. We probably could guess then what the angle phi is from the positive z-axis down is 3 pi over 4. Phi equals 3 pi over 4. But it's okay to try and verify this. There's lots of ways to go about doing that. All the conversion formulas are typically in the textbook, and this one shouldn't be too bad to do. But I'm going to do that a little bit in the next video, so I'm just going to skip right to our answer here. The spherical coordinates for this same point are radius from the origin in 3 dimensions is square root of 8. Theta was pi over 2, and the angle phi is 3 pi over 4. And there we have it. All done.